Hello everyone. In this video, we will explain an ARM assembly program that compares the average marks of girls and boys. The marks are stored in two arrays. Some values are -1, which means the student was absent. We will go through the code by step and show how it works. In the end, we will also show the output. So let's get started. Here's the problem. We are given marks of girls and boys in two separate arrays. Some students may be absentees and their marks are represented by -1. We are asked to compare the average marks of girls and boys, excluding the absentees. If girls having higher average, we display yes, otherwise we display no. This program is written in ARM assembly for the LPC 1768 microcontroller. It compares the average score of boys and girls, handles data in arrays, and stores the final result either yes or no at memory address 0x of 20001000. Let's go through the logic step by step. First, we load the base address of girls and boys, marks arrays into R0 and R1. We then initialize R2, R5 for storing total and counts. We loop through the arrays, skipping -1 values, summing valid scores, and then calculating average manually to avoid the division errors. Finally, we compare the two average and store the appropriate result. First, we load the base address of the girls array into R0 and boys into R1. We set 4 register R2 and R3 for girls total and count, R4 and R5 for boys total and count to 0. We also initialize R6 to 0. Next, we enter the main loop labeled loop. This loop will run 6 times from index 0 up to 5. When R6 reaches 6, we jump to done and exit the loop. Inside the loop, we first process girls. We load into R7. If R7 equal -1, we branch to skip girls and do nothing. Otherwise, we add R7 to R2 and increment. Then we fall through the process boys. Next, we load boys into R8. If it's -1, we skip the boys. Otherwise, add R8 to R4 and increment R5, which means boys count. After both arrays are processed for this index, we add 1 to register R6 and branch back to loop. This repeats until we've done all 6 entries. Once register R6 equals 6, we jump to done. Now, to avoid any divided by 0 error, we check if R3, which means girls count, is 0. If yes, set register R3 to 1. Similarly, if register R5 is 0, set register R5 to 1. Calculate girls average. We move the total R2 into R0 and count R3 into R1. We set R10 to 0. Now, in the loop labeled gdiv, we compare R0 and R1. If R0 is less than R1, we are done. Otherwise, subtract R1 from R0 and increment R10. By repeating this until R0 is less than R1, R10 ends up holding the quotient, girls average. Similarly, for boys, we move R4 into R0 and R5 into R1. Set R11 to 0. In the loop, bdiv, subtract R1 from R0 as long as R0 is greater or equal. Each subtraction adds 1 to R11. After the loop, R11 holds the boys average. Now we compare girls average in R10 and boys average in R11. If R10 is greater, we jump to girls I. In the no block, we load result address into R0. Then write character no and a terminator 0 into successive bytes. Then branch to end program. In girl's eye, we write YES, yes, and then a zero terminator. Finally, we enter an infinite loop at end program to stop execution. Data section. We define the girls and boys arrays exactly as shown. For our data, girls marks are 80, 85, minus 1. It is skip. 70, 90, minus 1. It is skip. That sums to 325. Count 4. Average it's 81. Boys marks are 75, 65, 80. Skip 70. Skip. That sums to 290. Count it's 4. Average 72. Since 81 is greater than 72, the program waits yes at 0x0 2000 location. The result using ASCII values. Each letter has a number. Y is 89, E is 69, S is 83, N is 78, O is 79. We store these characters one by one in memory. This is easy in assembly code because we don't use string functions. But the disadvantage is we can only show the shortcuts, not a full sentence. This confirmed by memory window screenshot on the screen. That completes the program flow from start to finish. So, this is how the ARM assembly program works. Thank you for watching.